Ben, what do we do today?
Today we are finding equivalent fractions.
And what can you do now that we finished the notes, Anna? You can write equivalent fractions. So based on the notes today, y'all can write equivalent fractions, yes or no?
Yes.
Okay, super important vocab. It always is super important. We got fraction, numerator, denominator, and then equivalent fractions. I did throw something at you in which you failed to remember that equivalent fractions were fractions with the same value. If you'll recall, when we were taking notes today, I asked you to reduce fractions and then ignore that big, huge 7. We're not quite sure why that got there. Then I asked you for letter B here. I said, find a larger equivalent fraction. And all of you told me that 1/2 had a larger equivalent fraction of 2/4 until you realize that equivalent fractions have the exact same value, right?
Yes.
So it's kind of a trick, but I really didn't know how to say it. We realized that we got to be very careful and pay attention to the wording of our problems. Yes or no?
Yes.
Okay? So, moving back up then, to find equivalent fractions, what do you have to find? In order to find an equivalent fraction, what is one thing you can do that we learned in our last lesson? Find what? Find the greatest common factor or find common factors. Does it always have to be the greatest common factor? No, if you don't find the greatest common factor, you're just going to have to continue to reduce it. But if you find the greatest common factor of the numerator and the denominator, then you don't have to keep reducing. Okay, so on letter A here, we found the greatest common factor of 3, the numerator, and 9, the denominator, and we reduced to 1/3. 2 you couldn't reduce, because 2 and 7's greatest common factor is 1. And for letter C there, we have 12 and 96, and we started by just dividing both the numerator and denominator by 2. And we realized that 648 still isn't reduced because 2 is not the GCF of the 12 and 96. Yes, no?
Yes.
Then we went the other way, and we took 1/2, and in order to find an equivalent fraction for a number like 1/2, or any number, you multiply the numerator and the denominator by the same number. So just to be clear on this one, if I have a problem like 3/17, can I find an equivalent fraction by multiplying the top by 10 and the bottom by 10? Yes or no?
Yes.
I certainly can, can't I?
Yeah.
What is 3 times 10?
30.
And 17 times 10 is 170, right? 3170 is the exact same thing as 3/17. Again, if you're multiplying the numerator by the same number as the denominator, you're going to have equivalent fractions. Just like if you're reducing the numerator by the same number you're reducing the denominator by, you have equivalent fractions, yes or no? You can go both ways on that, dividing and multiplying. And if that's still confusing, reread rule number 7, because that explains the whole thing. The last thing we have is this word problem about pizza. Don't worry about figuring this out. We'll talk about this when we get back together on Monday. I'm not even sure there's a solution to it. Honestly, I'm not sure there's a solution to it, but we can sure give it a whirl again on Monday. Any questions about equivalent fractions? Question? Real world. Yes, we are in a second, but not on the video.